Security and efficient internet traffic routing is really critical when you want to scale your private workloads. But managing this traffic without exposing your services to the public internet is really challenging. Hi, I'm Yash, developer advocate at DigitalOcean. And in this video, we will see how DigitalOcean's internal load balancer helps you by simplifying this whole process and scale your private workloads with security. So to start with, I have created a few designs to understand the problem and visualize the problem. So in this design, you can see I have 3 droplets deployed in the New York region, droplet 1, droplet 2, droplet 3. Each droplet have services running inside them. And droplet 3, the service which is inside in the droplet 3 want to access the services of droplet 1 and the droplet 2. To communicate with them, what we used to do is create a new droplet which act as a proxy server, and we have to manually set up all the things to do so. You have to set up a proxy server which can help droplet 3 to communicate with the droplet 1 and the droplet 2. Now, this is really a challenging and a manual task. It also becomes a single point of failure because if something bad happens with this particular droplet, it can make your whole application or infrastructure goes down, which we really don't want to do. To solve this problem, internal load balancer comes into the picture. It takes all the headaches of the load balancing and the traffic distribution from you. You don't need to set up those proxies by yourself. With just few steps, you can create a ILB, internal load balancer. And once you create that, you can connect your droplets with that ILB. So once I connect my droplets like droplet 1 and droplet 2, the ILB, I can access these droplets through the private IP of this ILB in the droplet 3. So my droplet 3 and the service which is running inside the droplet 3 can easily access these services. And if there is any service like droplet 2 is down, the ILB will make sure that the traffic request getting redirected to the healthier target like droplet 1. If we compare with other methods like direct IP access, is secure but not easy to use and not scalable at all. You can also use the public IP of the droplets with firewall policy, which is clearly not secure, complex, and not scalable at all. Internal load balancer is secure and easy to use and auto scalable with all the cases. But how we will do this same thing in the Kubernetes realm? Well, let's come over here and you can see that I have Kubernetes set up in the same region in the New York region, and the same droplet 3 is set up in the New York region in the same VPC network. You can also have a different VPC network and use the features like VPC peering. So now, once I have exposed the service as an internal load balancer in the Kubernetes managed Kubernetes cluster in the DigitalOcean, we will get the private IP which can easily be accessed by the droplet 3, and it can access the services running inside my Kubernetes cluster. In the later part of the video, in the demo, I will show you how you can create an internal load balancer for the Kubernetes cluster. So now quickly jump to the Cloud Console. Once you come to the Cloud Console, go to the left panel, click on the networking, click on regional and global load balancer. Once you click that, select regional, select data center and the VPC network, and select the internal private with network visibility. Once you select that, scroll down, configure extra configuration that you want to do, and create the load balancer. Since I have already created these load balancers, I'll go to the project that I have created. You can see that I have 3 droplets, droplet 1, droplet 2, and droplet 3 created in the New York 3 region. I also have a internal load balancer in the New York 3 region. So once I click on the internal load balancer, you can see that I have connected droplet 1 and droplet 2 with this internal load balancer. And in the droplet 1 and the droplet 2, I have a simple web server running. So from the droplet 3, which is also in the same VPC network, we will try to access the private IP of our internal load balancer and see if we are able to get access to the services running inside these droplets. So now what I will do, I will simply do a curl request to the private IP of the ILB. And once I hit that, you can easily see that I have got the response from the droplet 2. And if I click multiple times, you can see that I am getting response sometimes from the droplet 2 or sometimes from the droplet 1. It is because the internal load balancer is using round robin algorithm. Okay, great. So this is how you can do that for the droplets. Now, how we can do similarly for the Kubernetes cluster. So for our use case, I have quickly created a Kubernetes cluster inside my DigitalOcean account. And after I created my Kubernetes cluster, I have got access to the Kubernetes cluster in my terminal. So I have a service running inside my Kubernetes cluster. And inside the service, I have added a simple annotation, which is this, with internal as the value. Once you add this value in as an annotation inside your service and apply this service in your Kubernetes cluster, DigitalOcean will automatically create an internal load balancer for you for your managed Kubernetes cluster. So if I do kubectl get service, you can see that I have a service running as a load balancer with external IP like this. So this external IP is the private IP of my internal load balancer. So if I copy this, so inside from my Kubernetes panel, if I click on the cluster that I have created, and if I click on the resources, I can see the load balancer which I have created, which have the similar IP which I am able to see over here. So I can go to the droplet 3 again and try to ping my Kubernetes cluster internal load balancer because we are in the same VPC network. So if I do a curl request to the same IP, and since there is a server running inside my Kubernetes cluster which have a API as list, so if I hit that API, you can see that I have got my emojis as written because there is an emoji web server running inside my Kubernetes cluster. So I hope you have seen that how you can easily make sure a secure communication between your services and your private workloads, and you can also easily scale them. For cross-region communication, you can use the global load balancer, which you can see in the next video. Thank you, everyone.